Ladies and gentlemen, hello and welcome back. How you all doing? Thank you. The first rows are always the happiest ones, especially after the lunch break. So really nice to see you all here on this year's Infobip Shift Conference. I'm sure you all know the details about the hashtags and the prizes and the lovely things that you can do in these 2 days. But the most important thing is actually that you're here on the answer stage. So I hope you like how we divided the main stage into pizza slices, like Peter Hopwood said. So this pizza slice is called the answer stage, and I'm sure you're going to enjoy it. People are already gossiping about it, like, oh, it's the first developer stage, we need to go there and blah, blah, blah. So I hope more people are going to join us. But until they do, I'm not going to prolong my introduction because you actually came here for the superstars who are going to be here in front of their computers sharing their knowledge and experience. So without any further ado, it is a well-known fact that millions of developers all around the globe love and, of course, use Angular.js. So the logic behind only this one premise means that you absolutely love and cherish its creator, who is also responsible for Karma and Zone.js. Actually, you co-created Karma. So he is a major superstar, worked in superstar companies, of course, and knows everything from the web down to Transistor. Today, he is the CTO of Builder.io and will share his passion to make web fast for all of us. Ladies and gentlemen, straight from Saratoga, California to Zadar, Croatia, Misko Hevery! The stage is yours.
Thank you for the very kind words. How you guys all doing, and ladies? All right, so we had this super long talk, and at the last moment I decided to rename it for something shorter. Anyways, what we're going to talk about today is Google page speed and how to make your sites super fast and on Google page speed. So, first a little introduction. Hi, I'm Misko. I'm the CTO at Builder.io, and we are trying to make it possible for anybody to build websites. And because we're building websites, we're really interested in making sure that the websites are fast. And as was mentioned, I created Angular.js, co-creator of Karma, done clean code talk, so I've done a few things. Anyways, about Builder, what it is, it's a headless visual CMS platform. So here the word headless means that it's running on your infrastructure. Content management system, or the CMS, means that the marketing department can go ahead and segment their sections for like different segment markets, whether it's men, women, or children for the attire. So what you see over here on the right-hand side is Everlane. They're one of our customers. Their marketing department can change the UI at will, and the engineers can focus on the development of their product, and they don't have to be, the rate which the marketing department has to release their updates to the site can be independent from the engineers releasing their product. Anyways, the big thing over here that it is a visual editor, and this is kind of unique in the CMS space. And because it's a visual editor, it's a full drag and drop, and it can be used not just for building CMS sites, but really for building anything. And so our long-term goal is to actually have this visual editor available. But what I really want to talk about is how we use this to create really, really fast websites. So what Builder is kind of focusing on is making sites and e-commerce websites. And we want to make those e-commerce websites super fast. And we all know that this matters because Google page speed will affect your SEO rank. And of course, all of these equals money. The faster your website is, the more money you can, the better the conversion rates are. So, but if you look at e-commerce websites, and if you look at Google page speed, what you'll find is that they're not that good. Most of them are in the red. Some that try hard are in the yellow, and almost nobody is in the green. Getting 100 on a Google page speed score is super difficult and super hard. Now, there are people who always put together some demo small website or a small example, and they show off how they can do that. But as soon as the marketing department gets to it and they add their analytics and their other pieces of code, the site kind of becomes slower. And today I really want to talk about, why is it that we are in this predicament and what can we do to fix this? So what we're working on is a new way, a new framework, and a new way of thinking about this whole problem. And we call it Quick. And the goal of Quick is very simple, which is to have 100 out of 100 on page speed score under all circumstances. In other words, it doesn't matter how large your website is, you should always be able to get this. And we do this because we really focus on a couple of things. We focus on server-side rendering, and then we focus on something we call resumability, and I'll talk about it in a second. But if you look at the current generation of frameworks, they all claim that they're the fastest, the bestest. You know, I'm guilty of one of those in the list over here. But what you discover is that they're all really focusing on runtime performance once the application is booted up. What I'm talking about here is how do we get the application to boot up faster? Because once the application is up and running, you know, it doesn't really matter which technology you use. It's plenty of fast. The CPUs only get faster every year. So the speed of actually running the application is not the problem. What we really should be focusing on is how to get the application started up quicker, or the time to interactive is the magical thing that we should be chasing after. So let me show you the problem of what all existing, or I like to call them the current generation of frameworks have. We all start with server-side rendering, right? We render our code and we send it to the HTML to the browser. And the reason we do this is because serving static content is the fastest thing that the browsers can do, right? There's no way to get a site up and running faster than just serving it static HTML. But the problem with static HTML is, well, it's static. And what we want is we want to get into this box over here which says interactive. So I'm going to actually talk about the slides backwards. So what we really want is we want interactive site. Now, what does it mean for the site to be interactive? Well, it means that we have managed to register our click listeners, our hovers, our, you know, all the listeners that need to go into the DOM. And if you look at HTML, HTML doesn't contain that information. There's no way to send listeners where the listeners are present in HTML to the client. So what happens on a client is that you need to bootstrap the HTML that you got, the server-side renderer, and we call this rehydration or reconciliation. And you need to figure out where all the listeners are, and we need to register them. But how do you figure out where the listeners are? Well, for doing that, you have to get the template of the application, right? So right off the bat, you have to download all of the templates that you have on the page, and you have to execute these templates in order to figure out where the listeners are. But in order to execute the templates, you actually need the state of the application. So you also have to download the state of the application and execute this, and then reconcile everything, and then you can have it. Now, it turns out this reconciliation step is not actually cheap, both in terms of the amount of stuff you have to download, but also it's not cheap in terms of the CPU time involved. And so this big fat arrow really represents the fact that you're getting data twice. You're once getting the data from HTML, and then you resend all of the data all over again as the original JavaScript, whether it's JSX or JavaScript or whatever technology you happen to be using. And this reconciliation step here is really endemic to all of the current frameworks. All of the frameworks have this. And so if you choose any framework today, you will have this problem. And this is the problem that's going to keep you from getting 100 out of 100 on your page. So Quick takes a very different approach. So Quick, we start with server-side rendering. We send it to the client, and our pages are immediately interactable. We can fast forward everything and just go directly to the interaction. The way we do this is we embed little markers. Basically, the idea is that all of the state of the application that the application has should be serialized into the HTML, and therefore can be sent across the wire. And so I'll show you the demo in a second. What we serialize into it is the actual click listeners, where exactly they're located. And we sent a little tiny JavaScript. And I say tiny, I mean less than a kilobyte, and it executes in less than a millisecond. All of that this JavaScript does is it sets up a global listener for your browser. So if you click anywhere on a page, the click event bubbles up and goes to the root listener, and the root listener then figures out where the event comes from and looks for the onClick method attribute in a DOM, and based on that, it knows what code to download. Now, in this particular setup, it doesn't matter how complicated your website is. It can get as complicated as you want. You're always only going to be playing 1 kilobyte, and you'll have less than 1 millisecond bootstrap time. If you look at this setup, which is the classical frameworks, right? As as the page gets more and more complicated, then you have to download more and more code to rehydrate the page. And the thing to remember is that it's not just the page that you have to download. The thing is, these pages have listeners which have import statements, which import other things, and so on and so forth. And so it's like pulling on a thread of a sweater, and you kind of unravel the whole thing. So let's do a quick demo. So we have to have our obligatory to-do app. I am going to try to make the font a little bigger. If I refresh this page, nothing really exciting happens other than we have the to-do app. It's fully interactive. You can edit, everything you would expect out of it. That's not kind of the exciting part. What's exciting over here is, let's clear what's on here and let's just refresh, is that no JavaScript actually gets downloaded. You see this JavaScript over here is empty. Well, it turns out we do download about 1 kilobyte of it, and it's actually hiding right here. We actually inline the JavaScript into the index.html. The reason we do the inlining is because it's only 1 kilobyte, and the overhead of actually making the second request and processing it is actually so high that it's bigger than the payload that we're actually sending, and so it's easier to just inline the kilobyte directly into the index.html. You can see that it's actually 926 bytes. Now, over time, maybe this might grow to a little bit more, maybe 1 kilobyte or so. But fundamentally, as the framework gets more complicated, the complexity it goes into the lazy loaded bits, not into the initial bootstrap. What's in this 926 bits is really just the global listener. And it doesn't matter how complicated your framework gets afterwards, the global listener its responsibilities are essentially constant. It is to listen to things and route them to the particular location. So let's look at this input right here. So what you see over here is that here's our input, and it has a special attribute which is on:_keyup, and that is over here something that looks like a URL. And so this is how we serialize DOM listeners directly in HTML. And when they get shipped to the client, it shows the HTML shows up just like this. There is nothing for the client to do, right? The piece of code, this 1 kilobyte here that I'm showing, doesn't have to walk the DOM, doesn't have to figure out what things are. It actually has to do absolutely nothing. Because it's only when you click, or in this case, start typing the key up, it's only when I enter a key, only then does the event go up, and only then does the main loader figure out what's happening, and only then does the main loader discover that there exists an attribute over here that points to what looks like a header add to do. So if we go to network, you see it downloaded header add to do. Let me refresh this again. So only when I start typing does code actually get downloaded and executed. Now, this is nice, but really if this all there would be to it, we actually wouldn't be solving anything, because we would only be moving the problem from Bootstrap to the first interaction. And our goal here is not to just move the problem, but actually make the problem go away. So the thing you're going to notice is that as I interact with the page, the amount of code that is available here the amount of code that's downloaded will increase. So let me refresh this again. Me typing downloads a bunch of code. Me hitting enter downloads more code. Checking something off or deleting it all represents even more code. So as I interact with the application, I would like more and more code to download. The basic idea is that only the code that's necessary to get whatever the user is currently asking for should be downloaded. So it doesn't matter how complicated your application is or how large it is, right? The individual operations that user does are always relatively straightforward. So your user might say, I want to add an item to a checkout, or I want to see details of this particular product, or I want to change the image or something of that sort. All of these are relatively straightforward amount of code, and as the application gets more and more complicated, it doesn't mean that the amount of code that you have to download at each chunk gets more complicated. So this is basically the idea behind it. So we kind of talked about the first problem, which is that you want to delay the download of the code. But there's a second problem that exists over here as well. And that is the actual state of the application. So currently the application shows that there is 3 items over here. And I can, for example, add a new item. And when I hit enter, and I do know how to type, when I hit enter, it should update the number here, and as well as add the number of items in the list, right? That's kind of what you would expect out of the system. And as you can see, both of these things happen. And so a question really arises, which is, how did the framework know which components had to be updated on the page? So in a normal application, applications like React, Angular, etc., the answer is very simple. If you update the state or invalidate the state in some way, the framework essentially gives up and says, just re-render everything from the root. Start at the root and re-render all the components. That's pretty simple and straightforward, but the problem is that would cause us to download all of the application all at once, right? And what we're trying to do really hard here is to make sure that we download as little code as possible. And so we very much want to avoid this cascading effect where all of the page has to get downloaded all at once. And so we need to figure this out. And the only way to do this is to have a proper reactive system, in a sense that the component has a subscription to the data, and the data can go and notify a specific component that it has changed, and therefore the component has to re-render. And most of our frameworks are not reactive. Now, there are truly reactive frameworks out there, like, for example, Svelte. But the problem with truly reactive systems is that they need to download the whole world so they can execute and figure out where all of the, who is talking to who, and set up all the subscriptions. And so downloading the world and executing everything to figure out the subscriptions, again, defeats the whole purpose, because the purpose here should be to delay the download of the code as much as possible. So this is an interesting problem to solve. And the way Quick goes about it is that it tries to store absolutely everything it has in a DOM. So let me show this to you again. Again, I'm going to refresh. And what you're going to see that in this section, it is storing information about the data itself. So it's storing the fact that there is some record called to-dos. It has a primary key 1, 2, 3, 4. And it contains all the information here. Also, there is something called a record called item 1, a record called item 2, and item 3. And when the framework, when I enter a new item, I'm essentially modifying the record, the to-dos list. I'm adding an item to it. And so the question to ask is, what are all the components that need to be notified about the fact that I have just changed a particular record? And so we can achieve that by running a query. And so document.querySelectorAll, this is a standard API in a browser. And just by querying the DOM for a specific attribute, we get a list of components that need to be changed. So you can see that this component right here needs to be updated, and this component right here needs to be updated. And that makes sense, right? If I enter a new item, I have to change the list over here. So I have to definitely notify this component. And I also have to update the 3 items, the count from 3 to 4. And so that requires that the footer component be updated. As another example, if I go and edit item 1, then you can see that the node list says, yes, you only have to go and re-render this particular LI and nothing else. So how does this actually happen? So if we go to the specific LI, what we're going to see is that it contains an attribute that says where it can go and download the template associated with this component. And so the framework first sees that you've added an item into the list, into your storage mechanism. Then this store can notify the components that they have changed. And then the rendering system can go ahead and, based on this, figure out where to download the code for it and how to reload it. Now, if you look at a standard component, the way it is done in most frameworks, what happens is the frameworks kind of munch everything together in a sense that the template, along with the handlers, in other words, the click listeners, right, as well as the state creation and state update, is all together nice in a single file and sometimes even a single function. And when you put it all together in a single place, it makes it impossible for you to download everything independently. So let's look at over here again. Let's say I click on one of these filters and I only want to see the completed items, or I click back, right? Clicking here deletes existing stuff, which means I did not have to download any templates. But existing frameworks can't do that, right? If you determine that a particular component is dirty, you are forced to download a template for it. And with the template, you're forced to download all the behaviors of how this particular component works. And in Quick, because everything is separated, downloading the rendering portion of the component is independent from downloading the behavior. For example, when I double click on this, I would like to go into the edit mode. And I've had to download the item edit piece of code in order to be able to do that. And so editing the component and then hitting enter, again, all of these things get delayed and separated out as late as possible. So it is not enough to just be able to download individual components. You also have to be able to separate the components creation from the template from the individual listeners. To give a concrete examples, let's say you have a shopping cart. Let's say you add an item to the shopping cart. There's a difference between adding an item to a shopping cart and just incrementing the template count to clicking on a shopping cart and bringing the actual contents of the shopping cart out. The click, it has usually a lot more code associated with it than just updating the count that's currently available in the corner. And so we want to separate these pieces of code out as well. I lost my train of thought. Right. So the next thing is, the way to think about it, right, the next thing is rendering. In all of our existing frameworks that we have, rendering is a synchronous operation. In other words, at some point you say render, and the rendering pipeline expects everything to be available for it, and it just goes and does all the operations. And originally, when I started to actually build Quick, I wanted to reuse an existing rendering pipeline. So I was looking at either React or lit.html. And what I quickly discovered is that I couldn't use it because I actually needed a fully asynchronous rendering pipeline. I needed a way to tell the rendering system that, oh, pause the rendering while you go and download a particular template and then continue the rendering when the thing continues. But that's not enough. What you also need is something which I call a out-of-order component rehydration. What I mean by out of order is, in React, when you, for example, have a component, or sorry to be picking at React, really this is true for any framework, not just React. If you have a particular component that you want to re-render, there is no way to re-render just that component. The moment you say render component, it's that component and everything below it that goes, right? What I really want is just that component, because I would like to know, if a child component hasn't been changed, I've only changed an item. So for example, if you have a list over here, and I've added a new item, I've typed in something here and I hit enter, then I really have to just render this piece over here, and of course the for each that's above it, but I shouldn't have to re-render individual components that are associated here. Current set of frameworks can't do that, and they automatically re-render that as well. So all of these, it's kind of like peeling an onion. You start with the goal, and the goal is that you want to take our monolithic applications that we have, and you want to break them up into pieces so that we can run the application all at a time. And then you discover that as you do this, there are surprises waiting for you at each turn. You first have to solve the problem of not having to do the rehydration. Then you have to solve the problem of having the components be able to render independently from each other. Then you have to solve the problem that these components have state, and the state has to be serialized into the DOM. Then you have to solve the problem that the data has to somehow notify the components, and the components have to wake up and do the operations that they need to perform. So that's kind of a very fast overview. The last piece that is actually not covered here that we're working on is the bundling. So the way to think about it is that when you're building a standard way of building an application, you usually end up with a large chunk that represents your application. And then afterwards, you realize this chunk is too big, and so you want to somehow cut it up. It turns out there really is no way to cut it up magically. You have to go into the code and insert dynamic import here, dynamic import there, and then it's still not falling apart the way you think because there's like some hidden dependency, and it's an absolute nightmare to be able to do this. And so what existing frameworks really allow you to do today is they are really good at making this large chunk And then they say, as an exercise to the reader, you figure out how to break it apart. The difference about Quick is that from the very, very beginning, the goal of Quick is to produce lots and lots of small chunks. Now, of course, producing too many small chunks is a problem as well, but it turns out that's a problem tooling can solve. If you have too many chunks and you want to put them together, well, that's an easy problem for tooling. If you have a one big hairball and you want to separate it out, that's essentially impossible. So really the magic of Quick is that it allows you to write, not that it allows you, it guides you in writing the code in a way which automatically produces lots and lots of chunks in your code base. And then the tooling can go and figure out how to use these chunks. And so what we're expecting the tooling to do is we can sort, the runtime can keep track of which of these chunks are used, how often. And so the idea is that you build an app, you put it into production, and you observe how people use it. And from there, you collect information about what chunks are used when, or which parts of the applications are used when. And you can get a sorted list of all of the chunks. And this list is long, right? Because Quick is very, very fine-grained. You can easily have 5, 6 chunks, or even 10 chunks per component. And so you can end up with easily 100, even 1,000 chunks. And so you get them sorted by the probability that the user will interact with this particular thing. And then you can go back to the tooling and say, I want you to take the first 10 of them, produce chunk A, next 10 of them, chunk B, and so on and so forth. And if you decide that that doesn't work, you can produce a different set of chunks. Maybe you discover that if you have that there are two kinds of people, right? People who come to your site and they want to know what is the status of their order, and they use the app in a very different way. And then there is a set of people who want to look at the item and they want to just browse and figure it out. And maybe you discover that those two people actually need to be served different kinds of different chunk sets in order to make their experience the best. And you can do that because Quick fundamentally understands this. So it is a rendering pipeline that understands all the asynchronicity that comes with having multiple chunks from the beginning. Let's see, I've skipped over a lot of slides, but I wanted to kind of touch on a few things. One is, what is the philosophy here? And the basic philosophy here is that nothing is faster than doing nothing, right? While you can try to optimize how fast your rehydration can be, and I'm sure different frameworks are different good at it, at the end of the day, you can't beat the fact that Quick just doesn't have to do this step, right? There is no rehydration step. The only thing that the Quick has to do to get the application running is to just register a global listener at the root of the thing, and everything else kind of falls out of it. There are other interesting things that fall out of it. For example, there is really no... sorry, I skipped around here, so... there really is no bootstrap for the application either. Typical application, when the application runs in the client, there is this main entry point that you have to call to kind of get the application going. In Quick, there really is no main, because if I interact with the application by adding an item, then I really have taken a different journey and therefore a different bootstrap than if I interact with the application by deleting an item. And those two journeys will have different code downloaded and therefore a different entry point through it. So the other thing I wanted to point out is that rendering really is not fine-grained in the existing frameworks. We really are in this mode of, we just simply render everything from the beginning. And every time something changes, we just re-render the whole page. And so if you can somehow break this down and have individual components, it's as if you had an application and you have lots of tiny, small mini applications on it. And then each of these mini applications kind of live independently in their life cycle of when they choose to be re-rendered. It's kind of what you have to solve. So the mental model is figure out how to get everything in a DOM, and then DOM becomes a source of truth so that the Quick can easily wake up and just continue running. And this is my last kind of a thought that I want to leave, which is that I think if you look at history of how we got here, you can see that we came from building desktop apps, and therefore we built ourselves framework that think in a desktop-like ways. And we go out of our way to pretend that DOM doesn't exist. We have all these frameworks that essentially hide DOM and say, please don't look over here. It is something I will do for you, and it eventually will do the right thing. The problem if you do that, you're not really taking advantage of what the browser can do and what it can make it available to you. And so we have all these things like declarative UI. We can do lazy loading. We can do late binding. And none of these things are really expressed or take advantages of the current frameworks. And I think it is because of the history of how we got here. So anyways, in conclusion, you want to do as little work as possible. You want to be able to fine-grain lazy load the application as much as possible. It is DOM-centric, store all the state in a DOM, which makes for a reusable application, meaning the application can just continue running from where it started. And there is a place where you can check it out on GitHub. Also, StackBlitz folks have a way of running actually Node.js in a browser, and as a result, we actually have a demo running in the browser as well. Anyways, I thought you would enjoy that, and thank you for your time.